Okay, we have been looking at sine and cosine in a unit circle sort of way, which is a really good way. It's a little different from what you're used to, probably, talking about triangles. It's good because sine and cosine end up being related to rotations. So you can think of the unit circle as some sort of bar of length 1. And this is what it sweeps out as it goes around here. So that way you can see sine and cosine, this height here being, I have to make sure I get it right. Let's see, that's going to be sine. And this length here being cosine. Length up to here, and length up to here. You can see that sine and cosine are closely related to rotating circles, and that's sort of how, and they're related to periodic functions. And that's the big deal. That's why sine and cosine are so important. It's not really triangles, although in a lot of things it's easier to think of things in a triangle. But I want to make sure you know that these two things are equivalent. So if we have a 30-degree triangle, which is pi over 6, yeah, pi over 6 radians, 30 degrees, then we know that sine here, this length here is 1/2. Sine of 30 equals 1/2, and cosine of 30 is this length, which is square root of 3 over 2. It's just the length. If you calculate it out, it's 8.660 roughly. You see that number in your calculator a lot if you've done maybe 1,000 of these problems. Okay, so I want to show you that's equivalent. Today we're going to talk about the other trigonometric functions, which are not terribly important. Sine and cosine are the big things. And I want to show you that this right triangle approach is the same thing. So if we had a 30-degree triangle, and we know this angle up here is going to be 60. We won't write it in though. We know that the short side is 1, long side is 2, and the other side is square root of 3. We can use the Pythagorean Theorem, knowing any two of these to get the third one. These are a squared plus b squared equals c squared. Remember that. These two things are equivalent. So this side is 1, this side is 2. This side is 1/2, this side is 1. This side's square root of 3 over 2, this one's square root of 3. So this is the same triangle, just double the size. Alright, so the right triangle approach and the unit circle approach. Unit circle approach also tells you, makes more sense why sine and cosine go negative. You can see these measures become negative when this swings into these other quadrants. So it's not obvious on a triangle why an angle of 170 degrees is going to have a negative cosine. But over here it is, because you can see cosine runs along here and cosine becomes negative. And the length still stays 1. Alright, so the reason I'm talking about this, I want to kind of switch back to triangles for talking about the other functions. Sine, cosine are the big ones. The other ones are tangent, cosecant, secant, and cotangent. Okay, sine and cosine, again the big ones. Let me write the abbreviations for these. Sine is SIN, cosine is COS, tangent is TAN, cosecant is CSC. Secant is SEC, and cotangent is COT. This is pretty much the hard part of these. Sine, you remember maybe you had SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent was opposite over adjacent. Tangent, actually, the word tangent means touch. So actually, the angle, this angle here, this line here, the tangent line, the line that just touches this circle in one point. Something we'll talk about a lot in calculus. That tangent line, it's a little obvious why that's called tangent, and it relates to the ratio of these two things. So, nice thing about the unit circle is a little obvious why tangent of a circle and tangent, the function, the trig function, are related. Cosecant, actually, I think is Latin. I think Latin for cut. It ends up cutting the tangent. So that's where some of these words come in here. But we're not worried about that. That's just the origin of these things. We're going to use this triangle. Say this is the angle theta, and we're talking about right triangles. So this angle's 90 degrees. This is the opposite side. Adjacent, remember adjacent means next to. The adjacent house is the one next to you. This angle's here, the adjacent side is one there. This is the side that's across the street, opposite. Alright? So, tangent is opposite over adjacent. In a unit circle-y sort of way, here the tangent of 30 is going to be the ratio of these two sides, one side divided by the other. It's going to be 1/2 over square root of 3 over 2. Alright, you can see that you can simplify this. Either see that there's 2 in the bottom of each, so you can cancel those out, or flip and multiply and you get 1 over square root of 3. And you'll sometimes see that written as, I'll do it out here. Some people hate having square roots in the basement, and so they multiply by square root of 3 top and bottom, which is just 1, which is okay. You get square root of 3 over 3. That's another way to write 1 over square root of 3. I am happy with either way. I do not get offended if square roots are in the basement. Alright? So that's one way to think of, that's the way to think of tangent. So for these things, and notice I wrote secant with cosine and sine with cosecant. They go together. They're 1 over the other function. They're hypotenuse over opposite, hypotenuse over adjacent, and this is adjacent over opposite. These are 1 over their other functions. So another way to write that is that sine, well, let's write it the other way. Oops. Cosecant, which I'll write the most difficult way possible. Cosecant theta equals 1 over sine of theta. Remember that the cosecant goes with sine. It's not as you would expect. The cos do not go together. Secant theta is 1 over cosine of theta. And cotangent is 1 over tangent of theta. Sometimes we say this is the inverse. I don't want to mix up that notation for the inverse of a function. So I'm trying to avoid that. I'm saying 1 over. Alright? You can think of it in a unit circle sort of way, so it's not that helpful. So let's just do this for 30 degrees. What is cosecant of 30 degrees? It's going to be 1 over sine of 30. And sine of 30 is 1/2, so it's 1 over 1/2, which equals 2. Did I do that right? I think so. Secant of 30 is 1 over cosine of 30, which is 1 over square root of 3 over 2, which is 2 over square root of 3. Alright, and again, you may want to get that square root out of the basement. Just recognize that they're the same thing. This could be 2 square roots of 3 over 3. That's another way to write that. Alright, that's it again in a unit circle-y sort of way. So basically, think of cosecant, secant, and cotangent is going to be 1 over tangent of 30. So let's see, which we said was, we'll leave it at 1 over square root of 3. Oops. That's what, so this is 1 over square root of 3. Just ends up being square root of 3. Okay, that's about it. Those are the other functions. You find them by finding 1 over that function, or in tangent's case, you can think of it as dividing sine by cosine, but it's also just taking the opposite side divided by the adjacent side. These things are all closely tied together. And again, your calculator, I think, has buttons for these. That's fine. You will find you'll get the same answer no matter which way you do this. Take the function and find 1 over it, or plug it in your calculator. Alright, so we have a few problems on this. One brief thing I did want to mention, which we'll talk about more later when we look at these things, when we look at periodic functions. But we talk about functions being even or odd. If you had y equals x squared, this is even, which means that if you take a function and you put a negative number of x in, you will get the same function as if you put the positive number of the x in. If you had y equals x cubed, that's an odd function. It means if you put in a negative here, you get the same function out, but the whole function is now negative. Alright, so this means if you put in 2, you would get y equals 4. But if you put in minus 2, you would also get y equals 4. Alright, so that function's even. Whereas if you put in 3 to, this is y equals x cubed. If you put in 3, you get 27. If you put in minus 3, you get minus 27. Alright, so odd ones are mirrored but upside down, and even ones are just mirrored straight across this axis here. Why do we tell you that? Because cosine is even. So if you have cosine of t, it's equal to cosine of minus t. And sine is odd. So if you had sine of t, you know what that is, and you know that if you take the negative, that's the sine of minus t. Alright? So that'll help you solve some problems. If you know what a sine or cosine value is, you know what the negative of the angle is without even doing any work. You just change the sign if it's odd, or leave the sign the same if it's even. That's the last thing you need to do these problems. Alright? Pretty straightforward stuff.